Hello everyone, welcome back to the channel. So in the last video, we have discussed our problem statement of token classification, and also we have seen like what are the challenges and what are the possible solutions for those. So also we have seen like how we can get token embeddings from sentence transformer model, and in this video we will learn like how we can convert token embeddings to true word embeddings. Okay, so let us see like how we can do that. So as we have seen like there are two possible approaches. One is updating token embeddings, and the other one is updating labels. And as we decided that we will use the first approach, like we will convert token embeddings to true word embeddings. So we will learn that particular approach in this video. Okay, so let us see. So for example, we have the word lazy and it is being split into lay and gy. So we have three possible options. First is like we simply take the uh, subword embedding or token embeddings of the token lay, or we can take the token embedding of zy, or we can simply run a mean on lay and gy and get the embedding for the word lazy. Okay, so for example, if you have the uh, mm, subword embedding or token embedding for lay is this, and then we have token embedding for zy is this, and then we simply do in mean of subword encoding is simply we take the average of the dimension 0, which is like and take this and this, sum it and average it. Okay, that's what you get as a um, uh, true word embedding for the word lazy. Okay, and here is a simple pseudocode that you can think of. So for doing that, you need the tokenizer that is used in the model, and then you need to have embedding of all the segments. Okay, so in this case, we are considering like just one sentence, but in implementation, we will see like how we can simply iterate over all the sentences and embeddings and get the true token embedding, true word embedding for all the sentences. Okay, and then you need words, which is simply you split the sentence at white spaces, and then you need offset. So offset is simply like from where we will start extracting the token embeddings. So for some cases, I mean for most of them, this will start with one because they use a CLS token or beginning of the sentence token, which is BOS. But for XLNet, T5, and GP2, they don't use either BOS or CLS token. So that will start with 0. Okay, we will handle that in implementation. And then in for pooling, we have three options. We can either take the first subword encoding, we can take the last encoding, or we can simply run the mean on all the token embeddings of any particular word. Okay, and then we simply create a simple empty list. This will be used to like collect all the true word embeddings. Okay, okay, so now here is the main algorithm. So here you simply take the words and iterate over all the word we have here that we get from splitting the sentence on white spaces. Okay, you take the first word and then run the tokenizer on that particular word, and you will get the subwords. Okay, now you simply count that how many subwords are there, and then you simply extract the embeddings for that particular word. I mean, all the subwords that you have, you simply extract all the embeddings for those. For example, you have offset 0, offset 1, and then you simply say offset plus num subwords. Okay. So, for example, if you have these two, it will give us like two two vectors of 768 dimension. Okay. And then you can simply get the first. If you have specified the polling is equal to first, so it will simply get the 0th one from these all embeddings, and if it is last, it will simply take the last one, -1 using, and then if it is mean, so the last one, then it will simply run a mean on dimension 0 and then get the final embedding, and then you simply append it into true embeddings. Okay, and next you simply update the offset with offset is equal to offset plus num tokens. Okay, so number of subwords. This way you are kind of generating true word embeddings. Okay. Okay, so let us dive in and see like how we can implement it. So let us go to our IDE, and we have seen like how we can get the tokenizer in the last video already. Like we can simply take the encoder and simply get the tokenizer instance, and also we have seen like how we can get the token embedding simply changing the output value argument in code method. Okay, first let us handle the case like for XLNet, T5 and GP2 we should start with offset 0. Other than that we should start with 1. Okay, so let us say by default we say offset is equal to 1, and then if type tokenizer is equal to XLNet, then you can simply say offset is equal to 0. Okay, and also if type tokenizer is equal to T5, again say offset is equal to 0. Again if type tokenizer is equal to GPT2, you can simply say, okay, we forgot to add here, we can simply say offset is equal to 0. Okay, for these three they don't use BOS CLS token. That's why we need to start from the 0th index. Okay, and now so what we will do, this is like embeddings for all these 5 sentences. Simply let us see the size actually, so we can say simply print embeddings dot size. Okay, so we have this embeddings, which is actually embeddings for all these 5 segments. So this will be like a dimension of number of segments, which is 5, and then max number of subwords in any particular segment, and 768. So in this case it will have the max number of segments 18, then we will get like 5 cross 18 cross 768. Let us see that what it is. So let us run and see it. Okay, so it is actually 5 cross 15 cross 768. So the max number of subwords in this particular batch of segments is 13, and 2 extra tokens, which is CLS and separator token at the end. That's what we have here. Okay, so now let us iterate over all these embeddings as well as sentences. Okay, so what we will do is we will simply say for sentence and embedding in, we simply use zip, and we will say sentences and embeddings. Okay, so here we will get the first sentence for corresponding embedding, second sentence corresponding and embeddings, and so on. Okay, and let us say offset, or let us say subword offset is equal to offset. So we will start with whatever we get from this particular code block. Okay, next let us define like an empty list that we will use to collect the true word embeddings. Okay, let us say true embeddings is equal to an empty list simply, and next is simply what we will do, we will convert the sentence into words. by simply splitting on white spaces. So we can simply say words is equal to sentence dot split. This will split the sentence on white spaces and we will get the words. Now simply we will do like we will iterate on all the words. So let us say for word in words, and the next is we will simply run the tokenizer. So let us say it is subwords is equal to tokenizer dot tokenize word. Okay, this will give us the number of subwords, and let us say num subwords is equal to len subwords. And next we will simply say all embeddings is equal to embedding. So we will use this embedding and get the embedding for we will simply slice on embedding and get the get all the embeddings for this particular um, subwords. Okay, so what we will do is simply we will start with offset. No, not offset, we will simply say subword offset, and then we will simply slice over subword offset plus number of subwords. Okay, so you see, so we start like from, let us say it's first one, and then there are just two subwords, so it will be 0 to 2, so we will get 0 and 1 as the all embeddings. Okay, now let us condition on. So if, let us define one more thing here, let us say pooling is equal to, by default, let us say mean. Okay, and if pooling is equal to first, then we will simply return like let us say final embedding is equal to, we'll simply say all embeddings. So we will simply say all embeddings 0. L if pooling is equal to last, we can simply say final embeddings is equal to all embeddings minus 1. So minus 1 returns the last item of the list. Okay, else, I mean, by default, we will use mean. What we will do is simply average on dimension 0. So we will simply use torch. Let us append it. Torch dot mean, and we can simply say all embeddings and simply define dimension is equal to 0. Okay. And next is simply we append it into true embeddings dot append final embeddings, and next we simply update the offset, subword offset plus is equal to num subwords. That's our actually the final code of converting subword embeddings to true word embeddings. Okay, this true word embeddings will contain the word embeddings, true word embeddings for this particular sentence. Okay, sentence 1, sentence 2, and to collect all sentences we can simply say uh, create another empty list that will collect all the uh, true word embedding for all the sentences. Okay, so we can simply say sentence embeddings is equal to empty list, and we will simply collect it here dot append, and we will simply use torch dot stack to create actual uh, tensor for from the list. So we will simply say true word embeddings here. Okay, so this will be a list of tensors for all the sentences corresponding to uh, this particular sample text, and this will contain true word embeddings. Okay, so we will simply, we can iterate over and print it. So for emb in sentence embeddings print embedding dot size. Okay, so let us run and see it. So you see, this is like we converted token embeddings to true word embeddings that will correspond to the actual number of words. If we do white space tokenizer, that's what we get as a true word embeddings. Okay, so in this video we will stop here. In the next video we will learn like how we can create a model, and then later on we will see like how we can train it. Okay, so thanks for watching. Bye for now. Take care. See you in the next.